Welcome back, Math Marvels. It is the very first lesson, lesson 65 of a brand new unit, statistics and probability. In this lesson, we're going to work on understanding the probability of an event. This means it'll be a little bit longer than normal because we have some new information and new context to work on for the very first lesson. So while I'm modeling, watch how I express probability of the event as a fraction, how I convert the fractions as a percentage, and how I contextualize the event. This is going to be the newest part. How I contextualize it with words in the context of the problem and using a number line. Before I teach a model, let's talk probability. We've all played different types of games like Monopoly or flipping a coin, and we love these types of games because even if they're not likely, even if we know we're most likely gonna lose, we enjoy the thrill of the chance that we might win. And that's what probability is the way of measuring the likelihood or the chance that something can happen. And when we think of probability, we understand it on a continuum. So here's a number line that goes from 0 to, and I'm going to think of it as a percent, 100%, or in decimal forms, 1. So that's the way we're going to look at it. And on the left side, the 0, this is the never going to happen. The 0% chance, there's zero likelihood, there's no chance whatsoever. It is impossible going to happen. Versus on the 100 side, that's like we like saying keep it 100. This means it is certain. It is absolute. You know what's there. So this is certainty, absolute. It will definitely happen. And in the middle, we have the even chance. So you have an even chance of it happening or not happening. So as a decimal, I can say 50 hundredths or 50%. And that means I have an even chance of it happening or not happening. They're both equally likely to happen. So for example, think of flipping a coin. You could either get a heads on a coin or tails on a coin. That is a 50-50 chance. Now anything that is to the left of that 50%, we call this unlikely. So mathematically, anything that has less than a 50% chance, less than 50 hundredths of a chance, it is unlikely. And the closer it gets to approaching 0, it becomes less and less likely. On the opposite side, anything more than 50% is now in the likely column. You have a better chance of it actually happening. And again, the closer you get to 1 or the closer you get to 100%, the more likely it is to happen. So how do we represent an event using math? Well, we think of it in terms of numbers and outcomes. So in probability, when we talk about events, we represent it like this. The probability, this literally means the probability of X happening. And that's whatever the event is. This is the event that you want to happen. It's what's desired. Okay, it's that outcome that you want. And this number, whether it's a percent or a decimal, represents the ratio of your desired outcome, what you want to happen, compared to all outcomes. And we think of these in terms of numbers. So it's kind of dispassionate. We're just thinking about like, of all the outcomes, can we count all the outcomes in numbers? And then think of the things that we want to happen versus the things we don't. So I'm gonna give you 2 examples. And I'm gonna use a die to represent this. We played with dice before. If you've ever played Monopoly, we know it's a 6-sided cube. We know that on the cube, it has different numbers, 1, 2, 3, 4, 5, 6. So just a very basic die. Okay, when I have one of them as a die, when I have 2 of them, I call them dice. So what if I wanted the probability, I'm going to do 2 of them, the probability of just rolling a 1. So let's think about this mathematically. What's the outcome we want? We want to get a 1. So how many outcomes is that? That's 1 outcome. And how many things can happen when you roll a die? Well, 6 things can happen. So there are 6 outcomes. because 6 things can happen, 6 events. So that is my probability as a fraction 1/6. We can turn it to a decimal using division, so it would be 0 and 1600ths. This is a repeated 6, or you can change it to a percent by moving that decimal 2 times to 16.6%. And that's what probability is. It's taking this event and thinking about the number of outcomes you want out of anything that can actually happen in that situation. So on our number line, 16% will kind of be around here. Somewhere around here in the realm of unlikely, moving towards 0. But it's not impossible. There's still a 16% chance that it can happen. It's just not very likely at all. Think about this spinner over here. What if I wanted the probability of getting, let's see, getting a red? I would do the same thing. How many choices here are red? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, only 2 of them. So I would have 2 out of 8, which simplifies to 1/4. So in decimals, this would be 2500ths or 25% chance. And that's how we represent probability as a number. It's still unlikely because it's less than 50%. Take a look, annotate. I have similar notes in your handout today. Hit pause, jot down anything else you want to remember. And let's go into our first example. Michael is playing a board game. The probability that Michael will score a point on his next turn is 1/3. So there's his probability, 1/3. Which statement describes the probability Michael will score a point on his next turn? Okay, so if I'm doing my raise, we've already read it. This is absolutely an SP problem. So our key information, we know that the probability of getting a point is equal to 1/3. What we want to know is what word, what term would represent that. So my strategy is going to be to create a number line from 0 to 1, and I'm going to locate 1/3 on the number line. All right, and let's see what we can eliminate. So automatically, before we even go in there, I can absolutely eliminate certain and impossible, because there's not a 0% chance or a 100. So 1/3 has something to do with it could possibly happen and it can possibly not happen. So let's make our number line. Remember, you're going to put your 0, your 1, or 100. Some people like percents better. And I'm going to put my halfway mark. Anything less than 50%, unlikely. Anything more than 50%, likely. So this is going to be my key number. You're looking to see, is the probability greater or less than 50%? That's basically what you're looking for. Now we'll tell you if it's likely or unlikely. So since we have 1/3, I'm going to turn that into a decimal using division. Remember, you just read it from top to bottom, 1 divided by 3. And I'm going to get 0.33 repeated. It's just going to be repeated. Or 33.3%. So where is that? Is 33.3% more or less than 50%? Is absolutely less. So our event is going to be somewhere over here in unlikely. I don't have to get it exact, but there we go. Unlikely was our distractor. All right, hit pause so you can jot this into your notes. And remember, our key takeaway is to figure out, is it more, do you have more or less of a 50% chance? And that will help differentiate between unlikely or likely. And the closer that number is to either 0 or 100%, the more you're likely to see how uncertain or certain it is. Not only do I like comics, I like all things pop culture, including Stranger Things. So this problem is of course dedicated to season 4. Erica, Dustin, Will, and Mike are playing Dungeons and Dragons. Erica needs to roll a 5 or higher to defeat Vecna in the game. The die has 12 sides. How likely is Erica to defeat Vecna? So if you've never played Dungeons and Dragons before, they have different types of die, and they're not always 6-sided cubes. They look like this with multiple different sides to them, and you can see the numbers 1 through 12 written all over the die. So we want to know, is it likely Erica's going to roll a 5 or higher? Here's what we know. We know she uses one of these 12-sided die. We know the number on the die range from 1 to 12, and we know an outcome with a probability greater than 50% is likely. That's what we're looking for. So here's my plan. We're going to represent probability as a ratio, the ratio of a number of desired outcomes to the number of all the outcomes. We're going to convert that ratio from a fraction to a decimal or percent. That will make it easier for us to determine if the probability of 5 or higher is greater than 50%. Hit pause and jot this down into your notes. So we want to know the probability that Erica will roll a 5 or higher. So just so we can see what we're talking about, we want any number as long as it is greater than or equal to 5. That's what we're really looking for. So since it's a 12-sided die, let's think of all those outcomes. And there are 12 of them. There are 12 outcomes. All different things can happen. So how many of them are 5 or greater? Well, these are all the ones that are greater than 5. So there's 7. And we're also going to include 5 in that set because it's a 5 or higher, meaning there are 8 favorable outcomes. If any of those 8 things happen, then it is our favorable outcome out of all of them. All right, so we're going to figure out that probability. We can actually do that pretty easily. I'm going to simplify this to 2/3. So the probability P of a number of rolling a number greater than or equal to 5 is equal to 2/3. If you were to do this on your calculator, I'm just showing it out manually. If you did 2 divided by 3, you're going to end up with a repeating decimal of 0.6666 forever, or we can just round this to 0.67 or 67%. So is this a favorable thing? So think about it. On a scale of 0 to 100%, here's our 50%, are in the middle. We're right around here with 67%, where it is likely that she can get that number. All right, so let's put that into our final answer. How likely is it she can defeat Vecna? Erica has a 67% chance of rolling a 5 or more on her 12-sided die. This is a likely outcome. Yeah, so 2 out of 3 chances, that's pretty good. I take that. It's definitely over 50%. So it seems very, very likely, well, not perfectly, absolutely likely, but pretty likely that she's going to roll that die and escape Vecna. All right, so let's hit pause and jot this down into our notes. And that's it for today's lesson, Math Marbles. I hope you found this super useful. And again, just like I have to do when I have to think about all the outcomes, I sometimes have to draw them out visually so I can see what we're really talking about. That'll be a little transparent and honest. The first time I had done this, I had only marked the ones that were higher than 5, and it was only when I thought about it again, I could go back and correct that mistake. So for us to really know what these outcomes are, just slow yourself down, visually draw out or create a visual diagram of what all the possible things that can happen will be. Then highlight the ones that are favorable to the situation you are looking for. That's it for today, Math Marvels. I'll see you in lesson 66. Be well.